Assalamu alaikum everyone. My name is Abdullah Abbas and I am a student of Automotive Engineering and Technology in Punjab Engineering University. And today the topic of my presentation is application of metamaterials in automotive industry. Automotive industry has played vital metamaterials have played vital role in automotive industry, and now we will briefly discuss this in my presentation. So sit tight and watch till end. So, firstly, we'll talk about the introduction of this topic, and for introduction, I would like to give you the definition of metamaterial. Metamaterials are engineered materials with properties not found in naturally occurring substances. So, this means that you engineer them in labs and different plants, and they can't be found like any other natural source or material in mines like coals or in the ground like oil. And next I'll talk about their key characteristics. The key characteristics of they have a lot of unique characteristics, and a few of those are negative refraction, like they give you negative values when you refract light through them, and high strength to weight ratio, like they are very combusted, and so they don't weigh a lot, but they are very strong and very brittle, so they don't break under pressure, and they don't usually carry a lot of weight. And the last thing I'll talk about is tailored to electromagnetic waves. And so this means that it is very helpful towards the electrical parts of a car, which we use for electrical transmissions in a car. Car generally has a lot of electrical parts, so this is very helpful in that sense. And examples of metamaterials could be any photonic, acoustic, or mechanical metamaterials. So photonics are those which related to light, acoustic are those related to sound, and mechanical are those mechanical physical parts of anything. And their relevancy to automotive industry should be that they have potential to revolutionize cars, and they can bring in more car designs because metamaterials can be manufactured according to our liking, so we can them into many things, and they are generally safe because we may make them by ourselves, so we can be satisfy ourselves to according to our need. Thank you everyone. So this is basically the introduction to mathematics. So next, now we have metamaterials in automotive industry. Now we'll talk about their role in automotive industry. And firstly, I'm going to discuss about their impact on crash worthiness. Crash worthiness is like how they handle a crash. So when in metamaterials, generally use in metamaterials are generally very lightweight, but stronger, so they can support a car and be very light as well, and they have this ability to absorb the impact of a crash, like they divide the crash. When you crash into something, they divide that impact throughout whole the car, so they are very efficient in holding out a crash and not damaging us or damaging our car a lot. And example of metamaterial industry can be acoustic metamaterials. Acoustic metamaterials, like I talked about earlier, that those related to sound, and acoustic metamaterials are used to absorb sound, so they create like this sound barrier, so you can't hear a lot of sound and get annoyed during your travels to daily offices or schools, colleges, or wherever you go. And they absorb specific sound frequencies to improve overall driving experience, like they would absorb high bass sounds so that you don't hear a lot of noise and get like headache or other related things. And example of this could be any crash resistant panels used in metamaterials for energy absorption. A lot of car panels have these type of materials, so that explains the metamaterials. And so now we'll discuss about metamaterials for fuel efficiency. They are very fuel efficient, they have very lightweight design, like I have told you about earlier. They use structured materials, so like we can structure into anything. And lightweight means it consumes less fuel and is more efficient, because we can design metamaterials into anything in labs. And they use very lightweight materials. And second is that they are they aerodynamics, so we can structure any car's panels or body very aerodynamically efficient, because like we can manufacture them ourselves. So we can design a very aerodynamically efficient car body part, like their panels and external components to optimize fuel consumption, so they consume less fuel. And we can go to our daily work commutes very efficiently. So this explains their fuel efficiency. So now we are going to talk about their future and their potential challenges. And for future, I'm going to talk about their role in advanced applications, smart materials that change properties in response to environmental factors. They are very smart material, and we can customize them according to the temperature and what kind of temperature they need to be in to make that car work. So we can customize them according to their temperature, and we can customize them according to the different roads an area has. If area is not very developed and has bumpy roads, so we can develop these materials to sustain a lot of impact when we drive cars, so the car parts usually don't break down or things like that. And they have potential in autonomous ADAS systems. ADAS system are advanced driver assistance system, like most of electric vehicles have these systems. Like when you are busy, they drive car automatically. It's obvious from the definition of this system. And now I'm going to talk about their challenges. They don't have a lot of challenges, but there are few factors which have held back these metamaterials from getting integrated into our car industries. So first is high production cost of metamaterials. Like we make them in laboratories, or so they have high production cost. And because we take the materials and process them and then customize them according to our need, so this usually is very time consuming and very high cost. And so we are it's a slow process, but they are trying to make them very cost efficient, but it need an attention of everyone of big car companies to look into this matter. And then the scaling up of manufacturing process, we need to upgrade our manufacturing processes so it can be done efficiently and fast way, so that we can make more metamaterials and integrate them into our cars in short period of time, so that it becomes a key part of our any car in our industry. And this also needs some attention from big car companies or different governments like US or UK to enforce their car industries to make these materials used in our car industries. And so this explains their future and potential challenges in car industry.